Something arrived in our solar system last year, and the scientific establishment scrambled, not with panic, but with a kind of quiet, electric urgency that only happens when the universe does something it was never supposed to do. 14 space telescopes pointed their instruments at a single object simultaneously. NASA held emergency briefings. The James Webb Space Telescope, the most powerful eye humanity has ever built, was redirected mid-mission. SETI scanned it for artificial radio signals. The Perseverance rover on Mars paused its own mission and looked up at the sky. Think about what that means. A rover 140 million miles away on another planet stopped its primary scientific mission to photograph something passing by. And yet, most people on Earth went about their lives completely unaware that something ancient, alien, and scientifically unprecedented had just entered our cosmic neighborhood, swung past Mars, grazed the inner solar system, and left forever. This is the story of 3I Atlas, and the deeper you go into what was actually found, not the headlines, not the social media speculation, but the raw scientific data, the more unsettling and extraordinary this event becomes. There is a moment in science when the data stops being numbers and starts being something that changes your understanding of reality. That moment came on July the 1st, 2025, when a telescope in Rio Hurtado, Chile, belonging to the NASA-funded Atlas Survey System, Asteroid Terrestrial Impact Last Alert System, caught 4 faint images of a moving speck against the dense star fields near the center of the Milky Way. The object was already moving, not drifting, moving, with purpose that physics could not ignore. Within hours, follow-up observations began flooding in from observatories around the world. Amateur astronomers were cross-referencing archival images. Professional teams at the Zwicky Transient Facility in California were pulling pre-discovery frames from their databases, finding the object as far back as June 14th, 2.5 weeks before anyone officially knew it existed. And the more data came in, the more a single stunning conclusion crystallized. This object did not come from our solar system. It never orbited our sun. It never belonged to us. It came from somewhere else entirely, from the darkness between the stars, and it was cutting through our solar system on a trajectory that nobody had predicted, at a speed that our own gravity could not explain. By July the 2nd, the Minor Planet Center made it official. The object was designated 3I Atlas. The 3I means third interstellar object confirmed in human history. The first was Oumuamua in 2017, a bizarre, cigar-shaped rock that moved in ways that violated expectations and sparked a decade of debate. The second was 2I Borisov in 2019, an icy comet that behaved more familiarly but still carried the chemical fingerprints of a foreign star system. But this was different. This was bigger. This was faster. And according to the scientists who began analyzing it in the frantic days after discovery, this may be the most ancient object humanity has ever encountered. Here is where it gets strange. Based on its velocity components measured against the galactic coordinate system, the mathematical framework astronomers use to track motion across the Milky Way, researchers at Michigan State University and the University of Michigan calculated that 3I Atlas is somewhere between 7, 6, and 14 billion years old. Our own solar system is 4, 6 billion years old. The universe itself is only 13, 8 billion years old. What this means is that the object passing through our solar system in 2025 may have formed before our sun existed, before Earth existed, before the conditions that created life on this planet were even set in motion. It is possible, not certain, but possible, that 3I Atlas was drifting through the galaxy for billions of years before a single human being ever walked the surface of this world. And this is where everything changes. Because 3I Atlas did not just appear and disappear quietly. It followed a path that brought it alarmingly close to Mars. Not Earth, Mars. The trajectory was tilted at 175 degrees relative to the plane of the solar system, retrograde and angled at roughly 5 degrees to the ecliptic. It came in almost exactly parallel to the flat disk of the planets, but moving in the opposite direction from everything in our solar system. A ghost moving backward through a crowd. On October 3rd, 2025, at its closest approach to the red planet, 3I Atlas passed Mars at a distance of just 29 million kilometers. To put that in perspective, the Moon is 384,000 kilometers from Earth. Mars itself is, on average, 225 million kilometers from the Sun. This object passed through that neighborhood at a speed of up to 250,000 kilometers per hour, leaving behind a comet tail, a halo of gas, jets of material, and a cascade of scientific questions that astronomers are still trying to answer today. The orbital eccentricity of 3I Atlas, the mathematical measure of how curved or straight its path is, was measured at 6, 141, an eccentricity of exactly 1. 0 means a perfectly open escape trajectory. Anything above 1 confirms interstellar origin. Oumuamua had an eccentricity of 1. 2, 2I Borisov had an eccentricity of 3. 4, 3I Atlas came in at 6, 141, nearly twice the eccentricity of its predecessor and more than 5 times that of the object that first shook the astronomical world in 2017. This is not a gentle curve away from the Sun. This is a nearly straight line driven by a velocity so high that the Sun's gravity can barely bend it. Read that again. Our Sun, a star containing 99, 86% of the mass of this entire solar system, could barely deflect the path of this object. It came from somewhere so distant, with energy accumulated over so many billions of years of travel, that our most massive gravitational anchor barely registered. 3 NASA spacecraft observed 3I Atlas from Mars orbit and the Martian surface itself. The Mars Reconnaissance Orbiter trained its HiRISE camera on the comet from about 30 million kilometers away and captured imagery that would later be analyzed for months. The MAVEN spacecraft, designed to study the Martian atmosphere, pivoted its ultraviolet instruments toward the comet and captured the hydrogen halo surrounding it, a ghostly envelope of atoms being stripped away by solar radiation. And then there's the detail that stops you cold. The Perseverance rover, sitting on the floor of Jezero crater on Mars, raised its mass cam and photographed the comet passing overhead. A robot on another planet photographed an alien visitor from another star system. No science fiction writer could have scripted that. But nothing that came before prepared researchers for what the James Webb Space Telescope was about to reveal. Webb observed 3I Atlas on August 6, 2025, using its near-infrared spectrograph, a precision instrument capable of detecting the chemical signature of materials by analyzing how they absorb and emit infrared light. This was the first time Webb had ever analyzed an interstellar object. The preprint data, released shortly after, caused quiet waves through the scientific community. Then, in December 2025, just after the comet had swung past the Sun at its closest approach, Webb turned back toward it with its MIRI instrument, the mid-infrared instrument, and collected what NASA would later describe as the first mid-infrared chemical fingerprint ever taken of an interstellar object. What it found confirmed something deeply unsettling. 3I Atlas is not like anything in our solar system. It is chemically alien in ways that go far beyond its origin. Webb detected methane in significant, unmistakable quantities, alongside an abundance of carbon dioxide that scientists say is strikingly unusual. Our own comets, objects born in the cold outer reaches of our solar system, in the Oort cloud and the Kuiper belt, have compositions shaped by our sun's chemistry, our particular mixture of elements, our specific conditions during formation. The ratio of carbon dioxide to water in 3I Atlas suggests either that its nucleus is extraordinarily rich in CO2, or that some physical mechanism on this object is actively suppressing the outgassing of water, hiding water ice beneath an unusually thick insulating crust. A NASA team led by Martin Cordner proposed that if the CO2 dominance is real, the object may have formed very close to the carbon dioxide frost line of its parent star's protoplanetary disk, a region where temperatures and pressures are radically different from anything in our own system's history. Think about what that means. We may be looking at chemistry from a completely different solar system, from a star with different abundances of elements, a different spectral type, a different thermal history, and this chemistry has been locked in ice for potentially billions of years, preserved in the cold of interstellar space, and is now being released for the first time in our solar system's warmth. The water story becomes even more extraordinary when you bring in the results from the Atacama Large Millimeter/Submillimeter Array in Chile, or ALMA. Researchers from the University of Michigan, working with spectrographic data from the MDM Observatory in Arizona, conducted the first successful analysis of the water isotope ratio in an interstellar object. What they found was staggering. The water in 3I Atlas contains an extraordinarily high concentration of deuterium, heavy water, far exceeding anything measured in our own solar system's comets, asteroids, or planetary bodies. Deuterium is a heavier isotope of hydrogen, and its abundance in water is a direct fingerprint of the temperature and pressure conditions under which a body formed. High deuterium ratios mean formation in extremely cold environments, colder than the coldest regions of our outer solar system. This object formed somewhere colder than our Kuiper belt, somewhere colder than the Oort cloud, somewhere at the frozen edge of a distant alien planetary system, in conditions that our instruments had never had the opportunity to measure directly until now. And here is where the layers begin to compound. Because 3I Atlas did not just chemically surprise the astronomers, it surprised them visually. Hubble Space Telescope observations taken on July 21st, 2025, when the comet was 277 million miles from Earth, revealed a teardrop-shaped cocoon of dust enveloping the nucleus, a coma with a shape that distinguished it from typical solar system comets. Size estimates from Hubble data suggested the nucleus could be anywhere from 440 meters to 6 kilometers across. That upper bound matters enormously. 2I Jaborisov, the previous interstellar comet, had a nucleus estimated at roughly half a kilometer. If 3I Atlas's nucleus is anywhere near its upper size estimate, it is one of the largest interstellar objects ever detected crossing through our solar system, large enough to have survived billions of years of cosmic radiation and interstellar bombardment, large enough to retain its chemical secrets through the unimaginable cold of the void between stars. The Very Large Telescope in Chile conducted a high-resolution spectroscopic campaign through July and August 2025, using its X-shooter and UVES instruments, while the comet was between 4 and 2, 85 AU from the Sun. What they found when analyzing the coma, the gaseous envelope surrounding the nucleus, was a dominant reddish optical signature consistent with organic-rich material. Organic, as in carbon-based complex molecules, the building blocks of chemistry that, on Earth, is inseparable from the history of life. The reddish tint matched some of the most primitive bodies in the outer Kuiper belt, suggesting that, regardless of which star system formed this object, certain fundamental chemical processes may be universal. But there were differences, stark ones. Neutral nickel was detected in the coma without any accompanying iron. In our own solar system's comets, nickel and iron tend to appear together, released from refractory mineral dust under the influence of solar heating. The separation of nickel from iron in 3I Atlas's spectrum is something astronomers had not seen before. The VLT team wrote that if this continues, it would represent the first clear case where interstellar cometary metal emission is completely decoupled from classical refractory release, a new physical process from a different stellar environment, demonstrating that the universe has more ways to build a comet than we had imagined. By late September and early October 2025, the comet was approaching perihelion, its closest point to the Sun, swinging through at Marker Point, 36 AU on October 29th, just inside the orbit of Mars, moving at a maximum speed of 68 kilometers per second relative to the Sun. At that moment, Earth was on the exact opposite side of the Sun, which meant direct observation from the ground became impossible. But NASA and ESA had planned for this. Their spacecraft around Mars watched it go. ESA's Jupiter Icy Moons Explorer, JUICE, turned its cameras and spectrometers toward 3I Atlas as it passed through perihelion, observing the comet at its most active state, when heat from the Sun was driving the most intense outgassing. The data from JUICE didn't arrive back on Earth until February 2026 because the spacecraft's high-gain antenna was being used as a heat shield against the Sun's intensity, and data could only trickle back through a smaller backup antenna. By the time it emerged from behind the Sun in early December 2025, 3I Atlas had transformed. Astrophotographers who imaged it reported an unexpected blue color component and dramatically intensified outgassing. What had been a relatively calm, dusty comet approaching the inner solar system was now explosively active, streaming multiple jets from its surface in every direction, displaying a complex tail structure that photographers described as unlike anything they had documented before. On December 1st, 2025, new images suggested the comet may have been covered in what some researchers called ice volcanoes, eruptive features driven by trapped volatile gases, suddenly finding release pathways through the warming nucleus. The same day, theoretical astrophysicist Avi Loeb, who had been following the object since its discovery, proposed that the comet's brightness appeared to pulse with a rhythmic periodicity of approximately 16 hours, a heartbeat pattern consistent with a rotating nucleus with asymmetric activity. No scientific consensus emerged on that interpretation, but the observation added another layer of complexity to an object that was already defying easy classification. On December 19, 2025, 3I Atlas made its closest approach to Earth, BAR-1 8 AU, or roughly 270 million kilometers, almost twice the Earth-Sun distance. Far. Safe. But closer than any interstellar object had ever come to our planet in confirmed recorded history. That night, the Green Bank Telescope in West Virginia, the largest fully steerable radio telescope on Earth with a dish 100 meters across, was pointed at the comet for a detailed observation by the Breakthrough Listen initiative. The team scanned frequencies from 1 to 12 gigahertz. They were looking for narrowband radio signals, the kind that are not produced by any known natural process, and would be the unmistakable signature of technology, of intelligence, of something not natural. They found nothing, no artificial signal, no transmission, just the infrared glow of sublimating ice and the radio silence of a natural object following the laws of physics that were written before our solar system existed. But the absence of a signal does not mean the absence of wonder. The SETI Institute's Allen Telescope Array had already observed 3I Atlas for more than 7 hours back in July 2025, just days after its discovery, scanning from 1 to 9 gigahertz and cataloging nearly 74 million narrowband signals. After filtering for Earth-based interference and for signals matching the comet's precise velocity and trajectory, roughly 200 candidates remained for detailed review. Every single one traced back to technology on Earth or in Earth's orbit. The universe, as far as humanity could hear, had sent a silent messenger. The SETI researchers noted something worth sitting with. Eventually, our own Voyager spacecraft will be artifacts drifting through alien star systems. Whatever intelligence might exist around distant stars could theoretically send a probe through our solar system. And it might look exactly like a comet. Not because it would be disguised, but because the physics of interstellar travel at achievable velocities, combined with the heat shielding requirements, might produce an object that resembles a comet in almost every observable way. The scientists searched. They found nothing. But they noted how realistic the detection capability now is and why it matters to keep searching. The SPHEREX mission, NASA's infrared all-sky survey telescope launched in early 2025, turned its instruments on 3I Atlas in December and detected organic molecules within its coma, complex carbon-based compounds that, in our own solar system, are associated with the chemistry of prebiotic material. These are not life, but they are the kind of chemistry that, given the right conditions, participates in the emergence of life. Finding them in an object from another star system suggests something extraordinary. The chemical inventory needed to build life-forming molecules may not be unique to our solar system. It may be a recurring feature of planetary systems across the galaxy. The universe may be, in some fundamental sense, preloaded with the ingredients. On March 16, 2026, 3I Atlas passed Jupiter at a distance of 0, 358 AU, 53, 6 million kilometers, and ESA's JUICE spacecraft, now approaching the Jovian system for its primary mission, captured one final set of images. Even at 60 million kilometers of separation, the comet's distinct coma and dual tail structure were visible. Jupiter's gravity, the strongest of any planets in our solar system, bent the comet's trajectory by a tiny but measurable fraction. And then it was gone, outbound, accelerating back toward the darkness, heading toward the galactic plane, toward the thick disk stellar population it most likely originated from, toward a void it has crossed for billions of years and will cross for billions more. By the early 2030s, 3I Atlas will have passed beyond the orbit of Pluto. By mid-century, it will have left the heliosphere, the magnetic bubble that defines the outermost boundary of our sun's influence. And then it will be back in interstellar space, carrying with it the trace imprint of our sun's gravitational fingerprint, a barely measurable deflection of a few arcseconds in its long, nearly straight trajectory toward whatever lies beyond. It will never slow down. It will never return. It will drift for billions of years more through the dark between stars, until perhaps another solar system intercepts it, and another civilization, if one exists, turns its telescopes toward it in astonishment. What does this event actually mean? Not the headlines, not the clickbait, the actual scientific meaning. It means that the universe is in constant communication with itself through objects like this. Ancient travelers carrying the chemical records of long-dead planetary systems, launched into the dark by gravitational upheaval billions of years ago, crossing unimaginable distances to deliver their cargo to new neighborhoods. 3I Atlas's deuterium-heavy water, its CO2-rich nucleus, its nickel-without-iron coma, its ancient age, all of these are data from a star system we cannot see, from a time before our own sun existed, delivered to our doorstep and read for the first time by instruments we built within the last decade. The James Webb Space Telescope, launched in December 2021, was not yet 4 years old when it captured the first mid-infrared chemical fingerprint of an interstellar object. This is what it was built for. Not just exoplanets, not just the early universe. This, a messenger from another world passing through our own. And here is the question nobody is fully answering yet. The Vera C. Rubin Observatory came online in 2025, the same summer 3I Atlas was discovered. Astronomers predict it will detect 1 to 2 new interstellar objects every year once it reaches full operational capability. If that projection holds, we are entering an era where interstellar visitors are no longer once-in-a-decade anomalies. They become a regular class of observable phenomenon. Each one is a chemical sample from a different stellar environment, a different planetary system, potentially a different epoch of galactic history. The datasets that will emerge over the next 20 years could fundamentally rewrite what we understand about how planetary systems form, how chemistry distributes itself across the galaxy, and whether the conditions for life are rare or routine. But there is something even larger lurking beneath that question. 3I Sti Atlas came from the direction of the galactic center, from the Sagittarius constellation, from the densest, most ancient stellar regions of the Milky Way. The thick disk population it most likely belongs to is composed of older, metal-poor stars that formed in a galaxy less chemically enriched than the one we live in today. If this object is indeed between 7, 6, and 14 billion years old, it predates not just our solar system, but potentially the conditions that allow complex chemistry to flourish. It carries ice from a time when the galaxy was younger, cooler in certain regions, and structured differently. We are not just looking at an alien comet. We may be looking at a relic from a previous cosmic era, wandering through our solar system's moment in galactic time, like a photograph from before the album began. What we do with that knowledge is a question that transcends astronomy. Because the detection of a 3-eye atlas and the infrastructure now in place to detect future interstellar objects with ever-increasing frequency and precision means that humanity now possesses the capability to read the chemical history of the galaxy in real time. We can identify, characterize, and analyze material from star systems we will never reach. We can test theories about planetary formation against actual samples. Not theoretical models, not spectral guesses from distant stars, but objects we can photograph, spectrograph, and analyze with the full power of every instrument we have ever built as they pass through our own backyard. But the deeper unsettling question remains. If 3-eye atlas is the third interstellar object ever detected, and we have been actively searching for them for less than a decade with adequate instrumentation, how many have passed through our solar system before we had eyes capable of seeing them? How many have grazed Mars, swung past Jupiter, and returned to the dark without leaving any trace in human memory? How many chemical messages from alien star systems have we already missed? And if the Rubin Observatory is about to open the floodgates, if interstellar objects are about to become annual events, what are we going to find when we finally have enough of them to compare? What patterns will emerge across their chemistry? What commonalities and differences will begin to form a picture of how planetary systems build themselves across the galaxy? 3-eye atlas is already gone. It is somewhere beyond Jupiter's orbit now, decelerating imperceptibly against the sun's fading gravity, cooling again as the warmth of our star falls off across the distance. The jets that erupted from its surface are quieting. The coma that surrounded it is thinning and dissipating. The tail that stretched behind it is gone. The object that caused 14 space telescopes to pivot simultaneously, that paused a Mars rover, that made SETI scan for alien signals, that held Webb's instruments open for the first mid-infrared fingerprint of interstellar chemistry, that object is returning to the silence that has been its home for billions of years. And somewhere out there, right now, another one is coming. We just don't know it yet.